Hey guys, this is the answer key for our very first lesson. Now normally, here we go, wait a minute, oh, don't want green, want black, here we go. Number one, the first graph I asked you guys to draw was this guy. And like I said, normally I do not print or record a detailed answer key. I usually don't. I just post the answer key with the thing. But this is our very first lesson, and we covered a lot of ground, so I'm just going to go through this one so you can check everything and feel comfortable with your answers. So here we go. I'm going to go left 1 unit. I'm going to go down 4. I'm going to put a dot. This parabola opens upward, so I'm going to do this. And as far as your homework goes, this is all I'm looking for. Domain. It goes to the left forever. It goes to the right forever. Range. The lowest point on this graph is at -4, and then the graph goes upward forever. That's the answer to number 1. So I'm just going to go through these one at a time so you can check your work. Here we go. Number 2. And if you felt a little uncomfortable about it, hopefully by watching me go through all these, you won't feel so bad or apprehensive or whatever. Okay, so here we go. Problem number 2. This is a parent function of an absolute value graph. This tells me to go left 3 units and go down 4. I'm going to put a dot. It's not really called a vertex because it's not a parabola, but the parent function is a V-licious looking graph. Now, do not feel like I am going to take points from you because I made a wider V shape than you did, or a skinnier V shape than you did. What I want you to get out of this is knowing the way all graphs behave. So anyway, here we go. The domain. It goes to the left forever. It goes to the right forever. So that's what that's all about. The range, just like on my last one, there is a lowest value at -4. That's the lowest value it achieves. Then it goes upward. So even though they are two different functions, they have the same domain and range. Amazing. So anyway, let's go. Let's see what number 3 and number 4 look like. And remember, you may pause me at any time if you need to take a second look at something. So here is problem number 3. X minus 3 squared minus 5. Once again, it's parabolic, and there's no negative on the quantity squared. So I'm going to go 1, 2, 3 to the right, 1, 2, 3, 4, 5 down. And there's my vertex. Since it is parabolic, we can call it a vertex. But it opens upward. Hey, it's not the most precise, wonderful graph, but it gets the job done. What do we know about this? It goes left and right forever. And remember, the lower side, the less side, is always going to have the negative infinity. The other side is regular infinity. Never put a negative infinity on the right-hand side. And for the range, we use a bracket to indicate that it does actually start at -5 and it goes upward. Let's take a look at number 4. Number 4 was another absolute value graph, and I did this to you. I put a negative absolute value of x plus 3. Now this time I left this guy all by himself, so it's the same as negative absolute value of x plus nothing plus 3. If that makes your brain happy and you see what to do, then do that. But here we go. I'm going to draw a coordinate system. This means I am not shifting sideways at all, but I am going to go up 3 units. Boom. That's the top of my graph. And I've been flipped or reflected. So the V shape that I draw is now going to go down here. And domain. Even though it's going down, it is going left forever. Even though it's going down, it's going right forever. Domain does not care about up or down. Domain only cares about sideways. So here we go. Let's check the range. Now, once again, here's where you can make a mistake. This thing goes down forever. So negative infinity is always on the left side when you use interval notation. But the highest value this graph will reach is at 3. And then I put a bracket because it actually does reach 3. We use brackets when the value is achieved. So I said this in the lesson, whenever you graph something that has asymptotes, asymptotic behavior, you will never, ever see a bracket. You'll only see parentheses. But let's move on. Let's go to number 5 and 6, and we'll just keep going until you got them all. And if you just want to check your answers quickly, guess what? Normally, I just post an answer key. When you see the next video, you're going to see the answer key right there. But since this is our first lesson, I want to make sure everybody feels comfortable. Well, as comfortable as I can make you feel. So here we go. Parabolic. Let's graph it. You know it's going to open downward. 1 to the right. 1, 2, 3, 4 up. There's a dot. We'd call it a vertex, but we would sketch this graph going downward. That's going downward. Domain. It may be going down, but it's still going left. It may be going down, but it's still going right. Range. Remember, Mom always said negative infinity always goes on the left, and the highest value that will be achieved is 4. Bracket. Let's go on to 6. Number 6. Ooh, here we go. It's a square root graph. Now, here's the thing. Square root graphs always have that graceful, slow climbing arc look to them. That's what they look like. So I'm going to go 1, 2, 3, 4 to the right and up 1 unit. There's a dot. And here's the thing. This is what they look like. They just gracefully climb. Now, why do they do that? We'll go into that more. Remember, this is our first lesson. So I do know this, though. If you were to tell me the domain on this, it starts at 4. When you look at domain, it's the x motion. So at 4 is where it begins. And 4 is definitely an included number. It's not an asymptote. So 4 gets a bracket. And this thing goes to the right forever. What about the range? Well, the range, look at the y-axis, and you can see that 1 is the lowest value, then it goes upward as it goes outward. So that is the domain and range for number 6. Let's take a look at number 7, see what we got here. So number 7, y equals, once again, I have another root graph, x plus 1 plus 3. All right. Now, every moment I have is a teachable moment as far as I'm concerned. So you will notice this, that there are some functions where they may choose to write it like this. Some functions, they will do this to us. Now, that does not mean it's wrong. It just looks different. But this is to prevent somebody from accidentally saying, well, hey, is this 3 underneath the radical also? You know, I purposely made it look very separated. I'm going to get rid of that extra line. But those would be 2 separate statements then. This would still be sideways motion. If the value is next to the x, if it connects to the x, it's sideways motion. This guy is always up-down. The dude that's a singleton. If he's there, that's your up-down guy. So, as I'm going through this, hey, whenever I can think of something that'll help you get a concept, I'm going to throw it in there. So this guy still says go left 1, 1, 2, 3 units up. There's a dot. This guy's not flipped, so he is a graceful arc. Where does that graceful arc begin? It begins at -1, and it goes to the right forever. Range. I have a graceful arc, but the range only cares about where it starts on the y, and that's at 3, and then it goes up. Let's move on to number 8. So number 8, y equals rad x plus 2. Like I said, I'm making it very obvious. That 2 is not connected to the x. There is no connext with that 2. Therefore, this guy right here could be expressed like this if it made your brain happier. And then you'd say, oh, okay, I can sketch this graph starting at 0 for X motion, whoops, and then I go up 2 for the Y motion, and I'm a graceful arcer. There we go. Once again, domain, I would say 0, infinity. For the range, I would say 2 to infinity. Let's move on. Checking them off. Number 9. Y equals negative square root x plus 2 plus 4. All right, this is our first flipped one. So you got to be careful on this because things that are asymmetric, they don't look similar on the left and the right, are the hardest things to flip. I go left 2, I go up 4, but I got to tell you, I'm not flipping this way. Lesson 1, none of the graphs we're doing flip that way. None of them. So let's get rid of that guy. Here's the deal with this. If the original went like this, the mirror image of it would be down here. So let me do that again. If it helps you, sketch in the original faintly and then erase it if you have to. Because this is what that graph should look like. Now, here's the thing with this. Domain. I start at negative 2. I still go to the right forever, so the domain looks like that. But the range, remember, it's going downward. So if it's going downward forever, it doesn't go fast. I mean, it's going to keep going. Slow but sure, it's going to keep going down. That means going to negative infinity. And negative infinity is always written on the left side in interval notation. The highest value that will be achieved in this graph is a 4, and it actually does achieve 4. So when you're flipping something like a square root graph or a third power graph, they are the hardest ones to visually see because they are not symmetric on both sides. A parabola is symmetric on both sides, easy to flip, but a square root, not so much. So take your time, and if you have to, draw in the original function first, then do the next one. I call that drawing in a guide graph. But then please erase your guide graph. I don't need a guide graph. I know this one's going to go like this. Boom, I'm done. But I do this for a living, so I'm quick. Let's talk about the domain on this one. It's at 3. 3 is included. That dot is filled in, and it goes to the right forever. Will it ever go to the left? Yes, but not on lesson 1. Here we go. Range. This thing goes down. So negative infinity, the highest value it reaches is 1 bracket. Let's go on. If you need to, remember, pause it, rewatch it. You rewind what helps you out. That's what matters. Okay, so let's look at this one. Number 11. X minus 1 cubed plus 2. So here we go. Third power graph. It is a polynomial graph. We go over 1 to the right. We go up 2. We got a dot. And this guy's the twist. Now the twist, remember, these are rough sketches. I don't know if it goes through the origin perfectly right there. In fact, I don't know. I just want a rough sketch. I want to sometimes just have an idea where a graph is located. But here's the thing. I'm going to tell you, for anything that is cubic, so number 12, the next graph I'm about to draw, I'm going to have the same domain and range. It goes left forever, it goes right forever. It goes down forever, it goes up forever. No matter what you do to a third power graph, you will always have this. A polynomial graph like a third power graph, you cannot draw this thing. No matter what you do to it, it's going to have that domain and range. Now, the very next graph, what I'm going to do is I'm going to flip the graph third power graphs are really hard for some people to see visually how they flip. So just remember, like I showed you in the lesson, what's up becomes down, what's down becomes up. So you'll see it kind of looks now like a parabola going up and a parabola going down. Let me get rid of that because that's definitely not true. You'll also notice when I sketched that graph, I did it in two pieces. For some people, drawing one side at a time makes it a lot easier on them too. So let's go for the next one. I'm going to go over to number 12. And I hope if you were confused at all by any of my lesson 1 video, that this answer key video helps you out. And if you want, you're like, I got it, I totally got it now, thank you very much, then heck, you fast forward through a lot of this junk and I guess you ignore me. But like I said, same exact domain and range, same. Look, it's going to the right forever. Even though it's going down, it's going right. Even though it's going up, it's going left. Same domain and range forever. Okay, so let's move on. Number 13, we're almost there. But this is where we met our buddy, the asymptotic function. This was our first rational function. And when you draw a rational function, you have to pick up your pen in order to do it. This graph will move 2 units to the right, and it'll move up 4. That is like my new origin for this thing because I am going to have an asymptote here. Whoops, I dropped my pen. And I'm going to have an asymptote here. I didn't flip it, so according to what the parent function looks like, I'm going to use a different color for this. It's going to go like this. And then on this side, that's it. That's what they look like. Rational functions look that way. So let's go domain on this thing. It goes to the left forever. But when I go sideways, I have to pick up my pen at 2, and then I have to put it back down on the other side to draw the rest of the graph. When I do the range, it goes downward forever. But when I draw this graph, I have to pick up my pen at 4 and put it back down on the other side of 4 and sketch the remainder of the graph. So here's where I was a little worried that maybe you'd get a little overwhelmed or stuck. So here we go. Use the videos to help you out. So here we go. We're going to look at number 14. This one says -1 over x minus 3 plus 1. And since I haven't done this yet, I'm flipping this rational. So what's down is up, what's up is down. So here we go. I'm going to go 1, 2, 3. That is my new vertical asymptote. Vertical asymptote. And then I'm going to go up 1. And I'm going to sketch this graph. I'll use, how about green? Instead of going up into this upper right-hand quadrant, this guy's going to be flipped. So what's normally up is down. What's normally down is up. So if you compare this to the parent function on the sheet I gave you in the first lesson, down is up is down. But it still goes down forever. Where do you have to pick up your pen? Or sorry, it still goes left, because I'm doing domain. Still goes left forever. But at 3, there's a break in the action. At +3, you got to pick up your pen to draw the other side of this graph. The range, now here we go, down forever, but there is a break in the action at 1. I have to pick up my pen if I were to draw the other side of this graph. So that boundary line, wherever the asymptotes are, like this guy right here, there's a break in the action at 3. Guess what? There's a break in the action at 1. Chaw. See this guy? Faux show. Oh, totally. Oh. There's a pattern. Hey, guess what? There's a lot of patterns in math. So let's look at number 15. So here we go. Number 15. And if you're over it, I'm over it. I don't want to watch your answer key video anymore. Okay, just realize I don't normally do this, but here we go. X and Y. I don't go sideways at all, but I do go down 5. So what does that mean? That means my other asymptote is right here on the y-axis. That's where it is. It didn't move anywhere. Save a little time. I'm going to just use black and just do a black pen drawing. Boom. Oh my gosh, that is horrible. See, that should be asymptotic, means it wants to achieve that line, but these are rough sketches. These are not precise. So I'm going like this, and I go like this, and I go like that. And there's the thing that I did. Because there's a break in the action at x equals 0. Range. There is a break in the action at -5. That's where the asymptote is, and that is why I did it. And you'll notice my negative infinities are always on the left side, and my regular infinities are always on the right. All right, let's see here. I'm going to finish it off. I'm going to make it so, number 1. You know what? This guy, -1, x plus 2 minus 3. Just so you know, sometimes they'll write it like this in the book. Is it a different problem? No, it's the same thing, but follow the x. Whatever's connected, whatever's connects, that's this. Oh, that was horrible. Let me redo that. That's sideways motion. Come on. There you go. There you go. So I'm going to go left 2. There's my new asymptote. I'm going to go down 3. That's my new asymptote. I'm going to flip this graph. You better believe I'm going to flip it. Either way, it would be a flip graph because I'm negating the part that has the variable. Negating the part that has the variable. So what's up is down. And what's down would now be up. Okay. Domain. It goes, oh my gosh, my pen's getting iffy. It goes left forever. It has a break in the action at -2. Unified with -2 to infinity. Range. It goes downward forever. There is a break in the action at -3, which is unified with the other side of the asymptote, and that's what it looks like. And just a reminder, that's what the U stands for, unification of both sides of this graph. So where was I? That was 16. Let's look at 17. You know what? I'm going to do 17 and 19, and hopefully you got the point by then, because oh, man, I'm up to 23 minutes just for this explanatory worksheet thing. So here we go. This guy is the 1 over x squared parent. 1 over x squared parent. So this guy is not the same as the 1 over x to the first parent. So let's compare it. Here we go. This guy, come on, goes like so. I'm going to go left 4. 1, 2, 3, 4. Remember, if it connects to the x, it's sideways motion. And how do you know what motion it is? It's always the opposite, or what you'd have to plug in to make that thing say 0. So at -4, there is a vertical asymptote, which is a boundary line. That's what an asymptote is. Down 2. There is another asymptote. But this guy does not exist like a 1 over x graph. I'm going to change colors here. Let's go blue. Both pieces of this graph, it looks like the Atari symbol back when I used to play Pong in the 70s. Okay, and there we go. Those are supposed to be symmetric. My graph's not beautiful, but it's a rough sketch. It goes left forever. There's a break in the action at -4. That's where the asymptote is. I say that's where the asymptote is. Unified with whatever's on the other side, going to the right forever. But do not go on autopilot here. There's nothing below that horizontal asymptote. There's nothing below it. The lowest this will achieve is -2, but it's not included. It's a boundary. So do not put a bracket on an asymptotic function. Never on an asymptotic function. No way. And then it goes upward forever. That's what we look like. So I'm just going to do number 19 and call... Whoops. What the heck did I do there? Number 19 and call it a day. You guys, number 18 and number 20, you can hopefully, after seeing every single answer displayed for you like this, you know how to do everything. Hey, there's nothing here. That's why 0 was invented. Remember, nothing is 0. So if it helps your brain out, sometimes you have to draw the 0 in. Hey, do it. 0 is important to help us understand some concepts. So I'm going to draw a vertical. That's my Y. Here's my X. This thing has been shifted 1 unit to the left. Rough sketch. There's my asymptote. I haven't gone up or down, so the X-axis acts as my asymptote there. My graph has been flipped. So instead of going up, up, I'm going to go down, down. Let me get rid of those rough sketches in there. I'm going to use a red one. Instead of up, up, I'm going down, down. I'm going to try and make this one look pretty because it's my last one. Woo, that's pretty pretty. All right. Domain, it goes to the left forever. There was a break in the action at -1, unified with everything on the other side of -1. But the range, don't blow it. Will you ever put a negative infinity on the right-hand side using interval notation? No. It goes down forever. Negative infinities always live on the left. Negative infinity, where's the top of this? Where's the ceiling? Where's the boundary there? At 0. And is 0 achieved? No, it's asymptotic, so you never put a bracket on an asymptote. Never put a bracket on an asymptote. No. Okay, so guys, I hope that that was helpful if you got stuck on any of those problems the very first day. Now, somebody might ask me, well, why did you give us a homework assignment? Then just give us all of the answers. Because you don't know if you did anything right if you don't see the key. Every time I provide you guys with problems, I will give you the answer key so you can check your work. If you copy down my answer key and give it back to me, I am going to know it because you won't be able to do anything on the unit assessments. So, you know what? Not a perfect world we're living in right now, definitely not, but we're going to make the best of it that we can. So when you practice something, you check your answers. And if you're still confused by something, you can always leave a comment on the YouTube video you're watching so I see it. Or, you know what? You can ask me when we Zoom for roll time and everything. I'll always say, hey, anybody got any questions? And we can go over what you got. Okay, I hope you found that helpful. Have a